this section, we're going to be looking at histograms. We're going to start off by reviewing their basic components, and then we're going to look at how you construct your histogram of your own. Here we see on the right a typical histogram, and in fact a normal distribution histogram. So, looking here, we can see that the graph consists of bars of equal width. These can be drawn either adjacent if there's no gaps in your data categories, or a space between each bar if there is a gap. The vertical axis represents the frequencies, while the horizontal scale represents classes of quantitative data values, or they could also be qualitative data values. For example, if I had a distribution looking at how did individuals find out about the product that my company is selling, I might have categories in terms of from seeing a TV commercial, saw it in the newspaper, told about it by a neighbor, email, things like that. So I could also use those to make my classes along my horizontal scale if I wanted to. Notice the heights of the bars correspond to the frequency values. Thus, a histogram is basically a visual representation of a frequency distribution. Now, keep in mind that we can also make a relative frequency histogram. The only difference is the vertical axis is going to use relative frequencies such as percentages or proportions. However, remember, you need to be careful and label it as such. Notice also in this example that we have here that the second to the last category, 172 to 183, doesn't have any data entered there. That would be the case if you had a 0% for that class. So if you have a gap in a histogram, what that tells you is there was no data for that class. All right, now this is an example we have here is a normal distribution histogram. So in this type of histogram, we have the frequencies increasing from a maximum and then decreasing again. So the left half of the histogram is roughly a mirror image of the right half. So it's symmetrical. In a normal distribution histogram, the mean, median, and mode are all approximately the same score. So a normal distribution histogram is going to follow the same basic rules that we had for a normal frequency distribution. Now, we also can have skewed distribution histograms just like we had skewed frequency distributions. So let's take a few moments and look at these and look at the terms that we're going to use for each of them. So, on the example to the right is a right skewed histogram, and on the left, looking at heights of students, is a left skewed histogram. These are defined by the direction of the tail. It is very easy for students working with this data to make the mistake of paying attention to where the greatest amount of numbers are and assuming that that is what determines the direction of the skew. So if we were looking at the one on the right, we could see that the greatest amount of data values are occurring somewhere between 170 and 190. So you might be tempted to think, oh, well, that tells you the skew of the distribution. However, this is not the case. Let's take a look at this in a little bit more detail so we can understand it better. Notice, looking at the right skew distribution, if I cover up and get rid of those few small, very high numbers out on the end, the shape actually becomes closer to that of a normal distribution. So this is where the weight of my data values are, the majority of them. And if I work with only these, then I get a pretty normal distribution. However, when we add in these few extremely high numbers all the way out on the end, they pull off the shape of that normal distribution, and suddenly now I've got the skew. That's the tail pulling it and reshaping the distribution. So again, when you're looking at these and deciding on the direction of the skew, pay attention to the direction of the tail and think of that as being the small pieces of data that are altering the shape of the overall distribution. Okay, now we're going to look at creating a histogram from frequency data, and we're going to use the class pulse rate data from last time. So the first thing is you need to create a frequency distribution. So if you're working with raw data, you can't just skip straight to doing a histogram. You're going to need to make a frequency distribution first. So here we've got our class pulse rate frequency data from before. We're going to use the class boundaries as the dividing points for each of the columns along the x-axis. Okay, so here we can see 60 to 63 as being one of my class, my upper and lower class. Then we've got 64 to 67. Okay, so we're looking at, so use these all the way across. And this is going to create your x-axis. And then we're going to set our frequency rates along the y-axis. Now, let's take a few moments here and be clear about drawing these histograms. Each histogram will be custom designed to meet the data. So if I was working with data where I had frequency rates that went up into the hundreds, I would not use the same level of 0, 1, 2, 3. That would produce a completely humongous histogram that would be very unwieldy to work with. So instead, I might set my frequency rate marks by, say, 5 or 10, so in order to make it more consumable. So each histogram is going to be custom designed, both in terms of what goes along its x-axis and the frequency rates that you set along the y-axis to make the information easily understandable and still accurate. Now, the next thing is you're going to mark your frequency rates for each class on the chart and fill in below the frequency rate. So for the class pulse rate data, you should get something that looks just like this. All right? Take a few moments, work with the data, and draw in your histogram. Make sure it matches with this particular one, and then when you've got that set, move on to the next slide. All right, now we need to ask ourselves a question looking at this histogram. Is it a normal distribution? Why or why not? So take a few moments, pause the video, go through your notes, and look at what you have regarding the histograms and see if you think this is a normal distribution or not, and what would be your reason for your answer. When you've got that jotted down, let's move on to the next slide and we'll check them together. This is not a normal distribution. We do see that it does not follow the required pattern of lower scores on the left with higher scores in the middle, and again lower scores on the right. So it does not approximate the bell-shaped curve of a normal distribution. All right, and what I've drawn on for you here, the black line, is an approximation of the bell-shaped curve and what we expect a normal distribution to look like. This is going to be very important as we move further in the semester because certain statistical analyses, such as a t-test, requires a normal distribution. So you would need to be doing a quick histogram to be able to check and see, do you have a normal distribution before you begin to do any of your computations. Using a t-distribution when you do not have a normal distribution will still produce an answer, but it will be incorrect. If you want another look at what a normal distribution looks like, go back to the beginning of this and you can look at the shape that we had there. All right, now the next thing we're going to look at is comparing histograms by producing a back-to-back histogram. So just as when we were looking at frequencies and we want to be able to compare two groups, we can also do the same thing with a histogram by producing a back-to-back histogram. So for this, we're going to convert the relative frequency distributions of age and gender at time of winning the Oscar into a back-to-back histogram, working with the data that we already did with number 19. So let's take a look at that. To get you started, I've produced a beginning chart for you to finish filling in. Let's look at a few components of this. First of all, notice the class boundaries here are set as categories along the vertical axis. This is different than when you're doing a single histogram. So back-to-back means we put the class boundaries along the vertical axis, and then we put the frequency, or in this case the relative frequency, along the horizontal axis on both sides of the vertical axis. Now, let's take a few moments here to pay attention to some details. Notice, first of all, I've clearly labeled these as percentages. You need to be labeling your examples as you go along correctly. Mislabeling them or leaving partial information out, which basically is mislabeling them, is going to cause confusion and problems later. If you don't include the percentage marks here, it's going to look like what you've produced is a pure frequency distribution, which is not accurate. This would lead to misunderstanding. So be sure you're always labeling your information correctly. Notice I've also labeled one side as actresses and one side as actors. This is going to be really important if I need to come back and review my work later in prepping for the exam. Statistics rewards people who take the time to meticulously label things. This is not an area where going quickly is rewarded. It makes it easy for you to make mistakes. Leaving things unlabeled because you think it's obvious to you what it is now and you remember what it is, that's true for right now, but when you come back, say, in 3 weeks to review over your notes to get ready for the exam, you're not going to know which of these things are. It'll blur it into your memory. Then you're going to have to rework it all over again. And I don't know about you, but I hate having to rework a problem that I've already solved once before. It's a complete waste of time. So, as you're working through in this class, remember to take a few moments and correctly label each of your pieces of information as we go along. So, take this and fill in the rest of it yourself, pausing the video, working with your information, okay? And then when you've finished with that and you've got your back-to-back histogram, go on to the next slide and we'll compare them together. So, getting you started with this, notice that when we were looking at actresses at age for the boundaries of 19.5 to 29.5, we had a relative frequency of 32.9. So you can see coming out here along the left, I got to a spot that's approximately 32.9, drew that up, and then colored over to fill in my space. I did the same thing when we were looking at for the next category, which had a relative frequency of 41.5. And lastly, over on the right, you can see where I started working with the data for the actors. Here I'm using the color orange, and I filled in the space for 1.2%. So, pause this, go through, finish filling in your histogram yourself, your back-to-back histogram, and then when you've got that ready, move on to the next slide and we'll compare them. All right, you should have got something that looks like this. Okay, so notice I filled in the actual numerical amount as well. That's just a personal preference of mine because I like to have it if I come back to refer to the histograms later. You don't have to do that, but again, that's just an example of me being really careful about labeling everything. Okay, so when we look at this, we can see that we're looking at these that, again, the actors, the histogram more approximates the shape of a normal histogram than we see with the actresses. All right, this concludes this section on histograms. The next one we'll be looking at is other graphs and data plots.